Okay, so in section 9.5, now that you have learned how to simplify your square roots, whether they be involving perfect square numbers or non-perfect square numbers, or perfect square variables or non-perfect square variables, now what we have to do is start talking about how we can perform basic operations with radicals, okay? And the operations that I'm referring to in section 9.5 that we're going to take a look at are adding, subtracting, and multiplying of radicals, particularly square roots. And when we add, subtract, and multiply square roots, it is very similar to working with a variable. For example, if you have a 2x plus a 5x, well, if we want to be able to add these like terms, okay, first of all, what makes them like terms is that they have to have the same variable and the same exponent. And that's why we call these like terms. Once again, they need to have the same variable as well as they need to have the same exponent. And you may recall that when we do have like terms like here, basically all you have to do is perform the operation of addition by adding the coefficients of 2 and 5, and that's how we would get a 7x. Okay, or if we have, let's say, 3x squared minus a 7x squared, once again, we have these like terms. They have the same variable of x and the same exponent of being a squared. So if we want to combine these like terms, we would take the 3 and the 7, and you'd have to subtract them, and that's how you would get a negative 4x squared as your simplified expression. Well, adding and subtracting radicals is very similar in that we're going to look for what we consider like radicals. For example, if we were to follow like we had in the first example of 2x plus 5x, what if we had a 2 square root of 3 plus a 5 square root of 3? What we have here are like radicals. What makes radicals considered to be like radicals? They have to have the same root index. And in this particular case, they do. They are both square roots, okay? As well as they also have to have the same radicand. Now you may recall from section 9.1 that the radicand is the number underneath the radical symbol, and here the radicand is the number 3. So since they have the same root index of 2, the square root, and they have the same radicand of 3, we have like radicals. And just like the algebraic like terms, we have to take the 2 and we have to take the 5, and we're going to perform the operation of addition, and this would add up to a 7 square root of 3 as the sum of those two radicals. Okay? And believe it or not, the same would be true for, let's say, subtraction. If I had maybe a 10 square root of 7, and I was going to subtract a 3 square root of 7. Well, once again, we have like radicals because we have the same root index of the square root, as well as we have the same radicand, the 7, in which case now we have to perform the subtraction by taking the 10 and we have to subtract the 3, and that's why our simplified answer would be a 7 square root of 7 as the answer to that particular problem. What if we had this? Let's say we had the following. What if we had an 8 square root of 2 plus a 4 square root of 3 minus a 5 square root of 2 minus 9 square root of 3. Now, in order for us to add and subtract these radicals, once again, they must be like radicals, in which case we are looking for the same root index and the same radicand. Well, they all have the same root index in that the fact that they are all square roots. But there are two different radicands. There is the 2, as well as there is the radicand of 3. So we can only add and subtract those like radicals. So if I take the 8 square root of 2, as we see here, and subtract the 5 square root of 2, because those are the like radicals, that would give us a 3 square root of 2. Then if we were to combine the 4 square root of 3 and the minus 9 square root of 3, those are like radicals. Well, 4 minus 9, that would give us a negative 5 square root of 3. Now, we cannot combine this any further because we are dealing with two like radicals. Okay, we're dealing with a square root of 2 and a square root of 3. Those are not like radicals. We cannot combine the 3 with the negative 5. So this would be our final answer. So we can only combine, we can only add and subtract radicals if they are like radicals. Well, let's take a look at something a little bit different that may require something from a previous skill. Let's say we have the square root of 75, and we're going to subtract the square root of 12. Now here, you can see that, yes, they are both square roots, so they do have the same the same root index. However, the 75 and the radicand 12 are different. So we cannot subtract what we have going on here right now. So what we're going to have to do first is simplify the radicals. That's what we're going to have to take a look at first, okay? Because maybe if we can simplify our radicals, we might be able to form like radicals. So let's start with the square root of 75. The square root of 75, as we talked about in section 9.3, that could be simplified. 75 is not a perfect square. But if we were to use, let's say, the factors of the square root of 25 times the square root of 3, that would give us a 5 square root of 3. So 5 square root of 3 and the square root of 75 are the same radical. It's just that 5 square root of 3 has been simplified. Now let's see what we can do with this square root of 12. And let's see if we can simplify this radical. Well, the square root of 12, I'm going to break that up into the square root of 4 times the square root of 3. And since the square root of 4 is a perfect square, we can simplify that. That would give us a 2 square root of 3. And so now, by simplifying each independent radical, we have now formed like radicals, because they still have the same root index of 2, and they now have the same radicand of 3, in which case now we can actually subtract them. We would have to now take the 5, and we're going to subtract the 2, and of course 5 minus 2 would give us a 3 square root of 3 as your final answer there. Okay? So if you are initially given two radicals that are not like radicals, first we have to take a look about see if we can simplify the radicals, and maybe we can form like radicals as we did here. Let's try another example. let's say we have the square root of 32 plus the square root of 18. Once again, we don't have like radicals. Yes, they are both square roots, but they have totally different radicands, so we cannot add them yet. So let's simplify each radical first. Well, the square root of 32, that would give us the square root of 16 times the square root of 2. And since the square root of 16 is a perfect square, that would give us a 4 square root of 2. Now what we want to do is to simplify the square root of 18. And for that, I will use my factors of the square root of 9 times the square root of 2. And now that we have the square root of 9 as a perfect square, that would give us a 3 square root of 2. And so now what we have formed are like radicals by simplifying these previous radicals. And so now we're going to take the positive 4, and we will have to add to it the positive 3, and that's how we would get a 7 square root of 2 as your simplified answer. Okay, let me give you one to try on your own. Take the square root of 28, and then I would like you to, let's say, add the square root of, let's say, 63. So here's a problem for you to try. Take a moment now, pause the video, and try the problem on your own, and when you're done, let's see how you made out. Well, so if I simplify the square root of 28, I'm going to use the factors of the square root of 4 times the square root of 7. And since the square root of 4 is 2 square root of 7 now, okay, let's now do the same thing with the square root of 63. Square root of 63, I will use my factors of the square root of 9 square root of 7. And when we now go and take the simplifying the square root of 9, that would give us a 3 square root of 7. So by simplifying the initial two radicals that we were given, we have formed two equal radicals that have like radicals. Once again, because they have the same root index of 2, and they have the same radicand of 7. And so now, once again, what we need to do is simply add. We have this positive 2 and the positive 3, and when we add them together, we get a 5 square root of 7 as your simplified answer. Okay? So that's how we can add and subtract radicals. If they already have the same same root index and the same radicand, all you have to do is either add or subtract them. If you see that you have different root indexes, different radicands, then what you're going to look to do is to simplify each radical first and then perform the operation second. Okay? So that is your adding and subtracting of radicals. Now also in section 9.5, we have to address the idea of multiplying radicals. Now for that, we want to think back to a property that we had also in section 9.3 that involved the square root of a times b equals the square root of a times the square root of b. And this idea, the property involving multiplication, talked about we can distribute a radical over multiplication. And if this is true, then the opposite is also true. And that if I have the square root of a times the square root of b, that of course would give us the square root of A times B. So here we're going to take a look at how we can multiply the radicals. For example, if I had the square root of 2 times the square root of 3, that equals the square root of 6. And you always have to ask yourself, can I simplify this radical? And of course the answer is no, I cannot. So the square root of 6 is your final answer. Just like when you add and subtract, multiply and divide fractions, you always have to express your answer in simplest form. You're going to see here that when we add, subtract, multiply, and divide, you will always have to ask yourself, is the answer in simplest radical form? If we had, let's say, square root of 2 times the square root of 14. Well, this is going to equal to the square root of 28. Now, can I simplify this answer? And the answer is yes. Okay, so we have to be able to simplify the square root of 28, and we know we can. We're going to break that up into the square root of 4 times the square root of 7. And since the square root of 4 is the nice perfect square number of 2, square root of 7, that would be our final answer there. Okay, so here, excuse me, we had to perform the multiplication first. We wanted to multiply these radicals, and we did. We came up with a 28 as our radicand. And then you ask yourself, can you simplify that radicand, the square root of 28? And yes, we can, using, of course, the factors of 4 and 7. Let's try another example. Let's say we had a 5 square root of 6 being multiplied with a 4 square root of, let's say, 2. And we want to multiply these radicals together. Well, we're going to multiply the 5 and the 4. Because both numbers of 5 and 4 are on the outside of the square roots, we multiply them together, and that would give us a 20. But then we also have to multiply the 6 and the 2. And if we multiply the square root of 6 times the square root of 2, that would give us a square root of 12. But now remember, here comes the big question. Can we simplify this answer? And of course the answer is yes, because the square root of 12 can be simplified. So I'm not going to do anything with the 20, but the square root of 12, I could write that as the square root of 4 times the square root of 3. These mean the same thing. And since we know that the square root of 4 is 2, that has to now be multiplied with the 20, in which case now we would get an answer of 40 square root of 3. That would be your answer in simplest form. So we have to pay close attention when we multiply radicals. Numbers that are outside, as we see here, the 5 and the 4, we multiply them together. If we are multiplying radicals underneath, we have to multiply the 6 and the 2, the radicands. But then you always look to see, can you in fact simplify that expression? Okay, so you want to make sure that you always express your radicals in simplest form. Let me give you one to try. Let's say we have the following. Let's take a 7 square root of 3 being multiplied with a 5 square root of 6. Here we have these two radicals being multiplied. Take a moment now, pause the video, and let's see if you get the same solution as me. Okay, well, if we were to multiply our 7 with the 5, we would get 35. Next, we have to multiply the 3 and the 6. And so now, remember, we're going to have to multiply those two radicands together. And if we take the square root of 3 times the 6, that gives us a square root of 18. Okay. Now, once again, we have to ask ourselves, can we, in fact, simplify this radical? Well, let's take a look at the 18. The 18 can be simplified. I will use my factors of the square root of 9 times the square root of 2. And so now, since we know the square root of 9, that's a perfect square, that equals the 3, we now have to multiply, because multiplication is taking place here, the 3 with the 35, and that's how we would get a 105 square root of 2 as your answer. Okay? Well, we had said that the square root of a times the square root of b equals the square root of a times b. That's what we said earlier. Well, what if we had the square root of a times the square root of a? I'm going to tell you this is going to equal the square root of a squared. And the square root of a squared, that could be simplified to just a, which ironically here is the radicand. Okay, so whenever you multiply a square root times another square root, you will always get the same square root with the same radicand. You'll always get just the radicand. Think about it for a second. If I had the square root of, let's say, 5 times the square root of 5, well, the square root of 5 times the square root of 5, that would give you the square root of 25, which turns out to be a nice perfect square, and the square root of 25 is 5. And 5 was the radicand that we were multiplying together. If we had the square root of, let's say, 10 times the square root of 10, that's going to give you the square root of 10 times 10, which we know to be 100, which once again is a perfect square, and the square root of 100 goes back to, of course, the number 10. And 10 was, in fact, once again, the radicand. So we can actually cut out this middle step here, okay? Because if I had, let's say, the square root of 23 times the square root of 23, I don't want to be bothered with taking 23 and multiplying it by 23 or going to my calculator. I could simply assume that the square root of 23 times the square root of 23, because the root indexes and the radicands are the same, this is going to in fact equal 23. If I had the square root of 5,142 and multiplied it with the square root of 5,142, I know that this is going to equal 5,142. Okay, without actually performing the multiplication. Okay, once again, why is this so? Because the square roots, okay, the root indexes are the same, as well as these radicands are the same. Okay? Now, what you may recall in a previous section, previous chapter actually, if we had, let's say, x plus 3 times x plus 2. Here we were multiplying two binomials. And when you recall, we multiplied two binomials such as these, we said we can use that little FOIL method, and that we have to distribute. We would multiply the x with the x. That would give us an x squared. We would multiply the x with the 2. That would give us a plus 2x. Then you multiply the 3 with the x. That would give you a plus 3x. And then, of course, 3 times 2, that would give you a 6. And then, of course, what do you have to do? You have to simplify. And how do we simplify? Well, we're going to combine these like terms, in which case we have x squared plus 5x plus 6. We combine the like terms, and that would be your final answer. Well, the same would be true. Let's model something close to this. If we had, let's say, the square root of 2 plus 3 is going to get multiplied with, let's say, the square root of 3 plus 5. We want to multiply these two expressions together. Well, we're going to have to use a similar approach in that we're going to have to, once again, FOIL these together. Okay? So we're going to multiply the square root of 2 times the square root of 3, and that would give us a square root of 6. If we were to multiply the square root of 2 times the square root of 5, that would give us a 5 square root of 2. Then we have to multiply the square root of 3 times the 3, and that would in fact give us a 3 square root of 3. Lastly, we're going to multiply the 3 with the 5, and that would give us a plus 15. Always ask yourself in the end, can you simplify this expression? That's what we want to know. And of course the answer here is no. There are no like terms to combine. Even though we have a lot of different square roots, they have all different kinds of radicands. We have the radicand 6, the radicand 2, and the radicand 3. And because of that, since we have all these different radicands, we can't combine those radicals, in which case that would be your final answer. What if we had something like this? What if we had a 3 times the square root of 2 minus the square root of 7 plus 5 times the square root of 2 minus the square root of 7? Well, let's see what we're going to have to do here to perform the multiplication. Well, we're going to have to start by distributing the 3 over that binomial, and that would give us a 3 square root of 2 minus a 3 square root of 7. Then we will have to go and distribute the 5 on these two terms, and that would give us a plus 5 square root of 2 and a minus 5 square root of 7. As always, once again, we look to ask ourselves, can we in fact simplify this answer? And so let's see, we have a square root of 2 and a square root of 2. Those are like terms. So let's combine them by adding the 3 with the 5, and that would give us an 8 square root of 2. We then have a square root of 7 here and a square root of 7 here. These are also considered like terms, which means we have to take the negative 3 and subtract 5, and that would give us a negative 8 negative 8 square root of 7. Can this be combined any further? No. We have different radicals, therefore this would be your final answer to this particular problem. So we're using a lot of ideas in terms of how we work with radicals. They are very similar to how we worked with variable expressions. Let's try another one. Let's say we have a 4 plus the square root of 7, and we want to multiply that with a 2 plus the square root of 7. Well, let's multiply the 4 with the 2. 4 times 2 is 8. Next, we have to multiply the 4 with the square root of 7, and that would give us a plus 4 square root of 7. Next, we have to multiply the square root of 7 times the 2. That would give us a plus 2 square root of 7. And then we have to multiply the square root of 7 times the square root of 7. And remember, as we talked about earlier, way up here, that whenever you multiply a square root times itself, you're going to get just the radicand. So, using that idea now, where here we are multiplying the square root of 7 times the square root of 7, that would simply give us 7. Now, once again, we have to ask ourselves, we did the multiplication, can we simplify by combining our like terms? Well, we have an 8 here and a 7 here. Those are like terms. And of course, 8 plus 7, that would of course give you a 15. Then we're going to take the 4 square root of 7 and we're going to add the 2 square root of 7, and that would give us a plus 6 square root of 7 as our answer. Can't go any further. Do not, I repeat, do not combine the 15 with the 6, okay? Because you can't, all right? Because the 15 doesn't have a radical and the 6 does. Just like you wouldn't take 15 plus 6x, okay? You're not going to combine these into a 21x. That doesn't make sense, okay? That's nonsense. We're not going to take the 15 and the 6 square root of 7 because these are not like terms. Let me give you one to try on your own. I'm going to give you a problem similar to the one that we did, and let's see if you can come up with the correct answer. I'll post the problem here, and then you'll pause the video and then come back when you think you have your answer. Let's take a 2 plus the square root of 5, excuse me, and multiply it with a 2 minus the square root of 5. Pause the video at this point, work through the problem, and then come back when you have your solution. Well, if we were to perform our multiplication, we have to multiply, of course, the 2 with the 2. That gives you 4. 2 times the negative square root of 5 is a negative 2 square root of 5. Then, of course, we have to multiply the square root of 5 times the 2, and that would give you a plus 2 square root of 5. And then the positive square root of 5 times the negative square root of 5 is a negative 5. You have to be very careful of your signs. But remember now, here comes the big question. Can we simplify this further? And of course we can. We want to combine the like terms. We have a positive 4 and we have a minus 5. Those are like terms, and 4 minus 5 is going to give you a negative 1. Then let's take this negative 2 square root of 5 and add to it the positive 2 square root of 5, because they are also like terms. Well, negative 2 plus 2, that would actually give you a plus 0 square root of 5. But we know we can always express that in simpler form. We don't actually need that 0 square root of 5, so let's just write the best answer, the most simplified answer of negative 1. Okay. Let's work on another one. Let's take the square root of 3 minus 2 square root of 5. And then I have to multiply a 3 square root of 3 minus the square root of 5. Okay. Let's work through this one carefully. I have to multiply this 1 square root of 3 with the 3 square root of 3. And when I multiply the 1 square root of 3 times the 3 square root of 3, well, that I have to multiply the 1 and the 3 together. That would give me a 3. And then we have to multiply the square root of 3 with this square root of 3. And the square root of 3 times the square root of 3 is simply 3. And when I perform this multiplication now, we get the answer of 9. Now I have to multiply the 1 square root of 3 with the negative square root of 5. Well, if I was to take the 1 square root of 3 times the negative square root of 5, that would simply give us a negative square root of 15. Because we have to multiply the radicand of the 3 and the 5 together. Next, let's multiply the negative 2 square root of 5 with the positive 3 square root of 3. So if I take that negative 2 square root of 5 and multiply it with the 3 square root of 3, once again we'd have to multiply the negative 2 with the 3. That would give us a negative 6. And then if we multiply the square root of 5 times the square root of 3, that would in fact give us the square root of 15. So our answer there would be a minus 6 square root of 15. Lastly, now we have to multiply the negative 2 square root of 5 with the negative square root of 5. Well, negative times negative would be positive. 2 times the 1 would be 2. And the square root of 5 times the square root of 5 would be just 5. And since now when we multiply 2 times 5 together, we would get, in fact, a plus 10. Once again, we always have to say, can we simplify? And sure enough, we can. Because if we were to take the 9 and the 10, those are like terms, we get 19. And then we have these like radicals. Both have the square root of 15. And if we combine those like radicals, we would have to take the negative 1 minus 6. That would give you a negative 7 square root of 15. So 19 minus 7 square root of 15 would be your simplified answer. Let me give you one more to try. Hopefully you won't fall for the common mistake. What if we had, let's say, 3 plus the square root of 10 squared? So now we have a binomial of 3 plus the square root of 10, and we are in fact squaring it. Take a few minutes now, turn the video off, work through the problem, and then come back when you have your solution and compare it with mine. Well, hopefully you didn't make the common mistake. The common mistake, of course, as we've talked about before, is that students want to distribute the power of 2, that exponent of 2, on the 3 and on the square root of 10. And a lot of times students will tell me that the answer is 9 plus, let's say, 10, or simply 19. And this is incorrect. Because remember, when we square a binomial, what does that mean that we have to actually do? But what you really want to do is take the binomial and write it out twice. Okay, because that's what it truly means to square something, is that you have to multiply it by itself. And so now what we have is a problem similar to what we were working with prior. We would have to, of course, FOIL this. We would multiply the 3 with the 3. 3 times 3 is 9. Then we would have to multiply the 3 with that square root of 10, and that would give you a plus 3 square root of 10. Next, we multiply the square root of 10 times the 3. That would give you another 3 square root of 10. And then the square root of 10 times the square root of 10 is simply 10. We've performed all the multiplication that we could, Now let's go and see if we can do any further simplifying. Always want to simplify at the end. Well, we have a 9 and we have a 10. Those are like terms. And of course, 9 plus 10 is 19. Then we have a square root of 10 and a square root of 10. They also can be combined, in which case we'd have to take the 3 plus the 3, giving us a plus 6 square root of 10 as your final answer. So adding, subtracting, and multiplication of radicals is all very similar to when we worked with variable expressions, combining of like terms, foiling, and things like that. Okay? And that pretty much concludes lesson 9.5 on section 9.5. At this point, of course, there is more homework to be done. Try the problems on section 9.5 and see how you make out.